Hello, everyone.
Hi, everyone.
Hello, everyone.
So we'll be starting in a few moments, just maybe for 3 minutes more, and we'll be starting.
Just starting another meeting.
It's good to be busy, you know. I don't know. The person is on.
So just
Should I copy the link and send you?
okay, fine.
We didn't start yet. Huh?
No, not
We are still accepting people. They are coming.
yes, in the waiting room.
Nous avons Kelima de l'Algérie, de Tizi Ouzou, qui dit bonjour à tous. Bonjour Kelima. Hi Karima. Hi Karima from Algeria.
Are you sure that she's Karima from Algeria?
Yes.
Okay, welcome, Karima.
Most of the people are on mute. So. Okay.
Okay, bonjour.
So I think we will wait only 3 other minutes and we will start. So we will start in 1 minute.
Yes. Okay. Halfa, you can see my screen, right?
Right, I can see your screen. Yes.
Okay.
So I think it's time to start. Okay, so hi everyone. I'm Haifa bin Masoud. I'm a data scientist and I'm a founder of Our Ladies Tunis. I'm very honored to have all of you with us today in our meetup, Analysis of COVID data with R. So today we have with us Dr. Malouche. Dr. Malouche was my teacher for 3 years at University of Carthage, and also he was my tutor for my end of study project. So Mr. Malouche is a professor of statistics and applied mathematics at the University of Carthage. He has a PhD in statistics and applied mathematics from Paul Sébastien University in Toulouse, France, in October 1997. He also has a master's degree in applied mathematics from the same university in June 1994. Then he started his academic professional as assistant professor in Sousse in Tunisia. In September 2003, he moved to the Higher Engineering School of Statistics of the University of Carthage, and he was successfully promoted to associate professor in 2011. Mr. Malouche also has taught in Yes University. He supervised many PhD in applied statistics, and he has more than 50 research papers in many topics related to applied statistics and mathematics. So we are all honored to have him with us today in order to present his website COVID-19 done with the Flex Dashboard in R. So just before moving to Mr. Malouche, my colleague Muna will present Our Ladies Tunis in few words. So Muna, are you ready?
Thank you. Thank you, Haifa.
Okay, so the floor is yours, Muna.
Thanks. So, in fact, Our Ladies Tunis is the local chapter of Our Ladies Global, an organization that promotes gender diversity in the R community worldwide. We aim in person or virtually to learn about the R programming language, algorithms, and advanced tools. We are a group of Tunisian ladies passionate about R programming. We are from different backgrounds, data scientists, bioinformaticians, biostatisticians. You are Hedia, Haifa, Haitaf, Ines, Umayma, Khawla, Shaima, Kauthar, Nirmin, and Noor. Our priority is to provide a safe community space for anyone identified as a minority gender who's interested in working with R. We exchange materials, discuss any issues we have on working with R, and receive news and updates about R. We are really a part of a great community. Now I think it's time to start with Mr. Malouche. But before starting, dear participants, please feel free to ask your questions in the chat below as we go along, and we will be glad to treat them at the end of the workshop. The floor is yours, Mr. Malouche.
Thank you, Mona, for this presentation. And now it's the turn to Mr. Malouche. Hi, Mr. Malouche. Just
We can't hear you, Mr. Malouche.
we can't hear you. Your mic is mute.
Off.
Unmute. Do you hear me now? It's good.
Yes,
Yes.
it's okay.
Okay. Okay, I'll start again. So thank you, Munir. Thank you, Haifa. Thank you, all of you. I think all the committee of these Our Ladies. I know most of them because I think, as I saw, most of them were my student when I still in the Engineering School of Statistics in Tunis. I would like, first of all, to congratulate you for this kind of organization. And also, I'm not really surprised because maybe you don't know, most of you, the SAE is mostly a woman institute, actually. We have a majority of students, and we have also a majority of women teachers too. And even the direction and all the staff is a majority of women. So it's not a surprise, I think, that we start having the Our Ladies in Tunis coming from the people from the SAE, like we call it. Okay, so you know what I want to do first? I want to share my screen. It says I'm not enabled to share. Can you give me the permission to share?
Mona, could you give the permission to?
Yes, just 1 minute. Okay, now I think it's okay.
Oh, great. Okay. So where I am, okay, this is it. Okay. Okay, I hope all of you see my screen. Yeah, great. Okay, so I'm also very happy today to talk with you about a project that has started maybe 2 to 3 weeks ago. And it's a project about the COVID, because I think we, all of us now, concerned by this virus and this pandemic. And I will first give a short talk, some kind of slide like we usually do. And I will explain why actually I had started this project and what we can find in this project. And also I will finish by a demo, showing this website and how you can use it too. Okay, so let me start with the beginning. So why this project actually? So you can, I don't tell you something new, that this pandemic is now very important hot topic in the world. And actually, as a statistician, as a researcher, I was, like many people, very interested by this, and also was very interested by the data that is provided with this pandemic. And I wanted to provide something where anyone actually can get some really reliable information, can have a good summary of the situation, either in his country or maybe in a border region, like if you are in Tunisia, let's say, you may want what's happened in Tunisia, what happened in the Algeria, which is a neighbor country, and also in the North Africa, or maybe in the Middle East, or maybe in the Africa as a continent. So, and this kind of information, when I was looking to the data, I can't find it easily. But also, I didn't want something for only data scientists. I wanted something for open public. Anyone can understand, hopefully, what is the meaning of the numbers that will be on the website. Okay, so I think, I mean, I wanted something that you may not, I'm not giving prediction on this website, but at least you can know what's going on and what will happen with this pandemic in the next couple of days and maybe weeks too, okay? So, and there's another reason too. I mean, I'm some kind of data lover and I like playing with data a lot. So this is a very good exercise for me and I can talk about it to my student later. So of course, a website with the worldwide data about the COVID, there are so many, and I'm here giving you two good examples actually of websites. One is published by the Johns Hopkins University, I mean, super prestigious university here in the United States, with a lot of information. I mean, it's amazing how this website is beautiful. And you have some kind of live data too. So you will connect now and you will know maybe, I mean, you will know the number of cases right now. But I would tell you something, I mean, it's good to know the number of cases right now, but sometimes it's not really correct. So when you look carefully at the data. So it's important to get some delay about the data and to provide data 24 hours before, because there may be some change. Actually, the second website is published by the WHO. Of course, it's a big organization. And the WHO, actually, you can download data with a delay of 24 hours. And you can make also a lot of exploration. You can know each country, how many cases, how many days, etc. So the idea started by this, but I told you this is amazing website, but also I wanted something where we can learn more about the COVID. And something also for me, because I'm actually working a lot on this topic, and also make me to understand exactly what's happening with this pandemic. Okay. So I mean, this website was possible for mainly one reason, that the data is available, and can right away on R. So there are packages. So R, and mainly I'm talking about here 2 packages. Do you hear me? Because I see that the connection is unstable. Is okay? Hello?
It's
Yes.
although at some point it was not very good.
It's not clear. Okay, so interrupt me if you don't hear me, or even you have question. It doesn't. I would like to answer right away. So if you want to collect data about the COVID, worldwide data, you have 2 sources. So these slides are actually on the website. Okay, so you can download them and you can go to this link, and these are two GitHub packages. You can use them from R. But I mean, when you use them, you can see the data is really not accurate. Like, I'll tell you what kind of problems you may find. So you will have for both websites, for both data. So the first one is the Johns Hopkins University data. So, and it is also from the WHO data. So mostly it's the same data. But if you want, so you will have the total cases by day, by country, by locality, it depends at the level of the country. I mean, the country who provide data to the WHO. And you will have the total cases, the deaths, and the number of recovered people, okay? But if you want to compute the daily cases, in some country, it can be negative. I mean, it should be a positive number. Like for France, sometimes it's negative. For Japan, sometimes it's negative. So I don't know what is the reason for that. But if you go check to the second source of data, sometimes these days are not actually negative too. So you have to work a lot. I mean, I don't know the public here, but if there are many statisticians here or data scientists, I mean, you know, actually what is difficult to make data clean. I mean, sometimes it's, I mean, you know, no one will think that it's a lot of work, but it is. So anyway, so I wrote our code here to try to collect data and that makes sense. Only positive cases for daily cases. So I need also to know what I call the, I mean, I don't call the active cases, which is the number of currently infected cases. It is the total case minus the death and minus the recovery. And this one has to be also positive every day, okay? So first of all, I can show you later the code. I mean, it's a long R code to have this, and then to compute the statistics by regions, by all over the world, and then we have a data that it can be used right away on R. So the website is mostly, so it's a visualization of a data set. So I decided here to use Flex Dashboard. I didn't want to use Shiny, by the way, because sometimes, you know, I found that Shiny for normal people, and I'm not talking about data scientists, it's not that easy to use. And I'm targeting also a large public. So actually, I don't have a paid account on Shiny. And if you want to have a lot of visit on your Shiny, so it may bug actually after a number of times. So I wanted something easy so you can use it over your phone or over your desktop. So I said, let's try with the Flex Dashboard. And sometimes when it's a little bit tricky, I can put some Tableau Dashboard on the website too. So all together, so I made, it's a lot of programming. So if one of you had already visited this website, it contains, I think, about 250 something dashboards. So actually, I mean, this dashboard are made by Flex Dashboard. So it's some kind of Air Markdown template. Of course, I don't write the 250 dashboards. So what I do, I write an R code who writes this dashboard and generate this dashboard. So, and what I have to do every time I have to update this website. So I have to update my R code. I mean, I have to run the R code. So when I wake up in the morning, first of all, I run my R code that collects the data and make the data clear. Then I execute the R code who writes all the 250 dashboard, and then I use GitHub to publish the website. So all this is happening from RStudio. Okay, so it is actually a GitHub website. What I did, I just bought a domain name for that, which is the COVID-19 data.website. This domain name is not that expensive. It's about $4, so it's like a coffee. Okay, so, and it's easy to memorize for everyone. So then, this is it. This is the domain name of my website. So what you, I mean, when you so go to my website, what you can find. So this is a 24-hour update website. I told you I didn't want to choose the live streaming website because there's still some, I think there's still some problems on the data, because this data is collected from many other sources, and sometimes I think the countries update their own data too. Okay, so I prefer also waiting 24 hours, collecting my data, and then updating my website. So what you will have this statistic that we can find everywhere in like the website that I had showed before. So you have the number of cases, the number of deaths, the number of recovery, the active cases. And also you will have this same statistic by 1 million population. So the statistics are useful to compare between countries. So we actually divide by the size of the population, and it's easy to compare between. Then, and two important information too is the mortality rate. So what we call the fatality rate. It's the rate between the confirmed cases, the total cases, and the death. And this mortality rate, it changed a lot between countries. I cannot give the reason now, but I think researchers will think about it a lot and will maybe give us answers. And another important indicator is the active rate, which is the rate between the active cases and the confirmed cases. And this will be, I will show you later, as an indicator that can help us to understand if we are starting some kind of decreasing phase of the pandemic in such a country. And the second stage, so I provide some growth indicators too. That's so I want to show to people. So people of, the disease, of course, is affecting countries, but it affecting countries with different speeds. So I want to show this on the website. The third or the fourth thing I show in this website is the statistic by regions. And this is not easily available if you look to the other website. And especially there's a region by incomes, by economics level. And these economics regions are a definition from the World Bank database. Okay, so these are maybe you can find this information, but this is or on the website. But this is I think that two important things in this website. I think you cannot find them easily in other websites. So the first number, the famous number of the reproduction number, so I will talk about it. And I provide a country classification. I will explain how is this country classification later. So the reproduction number is very known as the number that estimates how many secondary cases are likely to occur in a specific region. So I give you an example. If this number is about 1.38 or 1.3, it means that in that region, in that area, 10 persons can contaminate 13 persons. So then we can understand that this the pandemic is still growing in that area. However, when this number is less than 1, we can think that this pandemic is going through a decreasing phase. Okay. However, there's a big problem for this reproduction number. It's very sensitive to the number of cases, especially when we are in a situation where we have 3, 4, 5 cases. So let you tell you something. If yesterday we have 7 cases, like in Tunisia, and today we have 4 cases, we may quickly go to RT greater than 1. So you have to observe this RT, this reproduction number, at least on the 7 previous days. And for the estimation, actually, I use again R, and I use a package in R called APStim, and where you have to plug actually the parameters of the algorithm, base it so on a paper. I mean, it's still also in my website. I will show you where it gives some parameters about the virus, the incubation period, this kind of. Okay, so I will be estimating this for every region, country, area, everything. So you can quickly understand if we are in a phase where the pandemic may be decreasing or is still growing in that country. Second thing, so a lot of countries, and most of the countries are opening their board, they provided classification. And so I look to some of the criteria. So I think, And I say, you know what, let's try with this kind of criteria. I don't know, maybe. So I said that, yeah. So let's see to this criteria and let me provide another classification. I don't say it's the best one, but it's a classification. At least I provide all the explanation about it, and you can understand why I'm classifying a given country or a region in that way. So first criteria, remember I have talked to you about the reproduction number, the RT. So I will look on the 7 previous days to the RT, and I will give 1 if in this country, if on the 7 previous day, I had at least observed that the RT is less than 1. As I told you, this RT is varying a lot. So when it's less than 1, at least in the majority of the previous days, so we are really in a decreasing situation. The second criteria is the active rate. So the active rate is when the pandemic starts in a country, it grows. And then it will reach a peak or a plateau. And then it will start decreasing. And then we are in a phase of decreasing, actually. So, and this is actually, so if you heard a lot of the news about the COVID, we always talked about peak in the COVID pandemic. According to me, there are 3 peaks, actually. There's not 1 peak. So this is the first one. So I will be observing this active rate in the previous 14 days. And if it's decreasing in at least 7 days, so I'll give a 1. Okay. Are you okay? Okay. So the third criteria is the daily, the number of daily cases. Same thing, it behaves like the active rate. It starts growing, it reaches a plateau, it goes into a decreasing phase, and maybe we will have some kind of end of this pandemic. So same thing, I wanted that this number of daily cases decreases at least on 7 days. This is, I told you, it gives me the second peak of the pandemic. The third one is the number of daily deaths too. So same thing, it goes up, it reaches a peak, it goes down, and I will give 1 when at least on the previous 14 days, I will have 10, because why 10? Because I found that the death, it's really a good indicator of the situation of the disease, of the pandemic in a specific country. Then I wanted to also use 2 criteria based on the statistic by 1 million population. And I wanted that the cases in the 7 previous days doesn't exceed the 21, like 3 with the average 3 days, 3 cases by day, 3 cases by million. So the size of the population is not important here. And I will do the same with the number of deaths by 1 million population in the last 14 days. And I want this number be lower than 14. So an average less than 1 death by day. Okay. So I will be observing this criteria from the today to the 14 days. And I will, this is like a statistical rule, I will compute the sum. So the score at day T will be less than 6. So of course, if I satisfy the 6 criteria, will be 6, and then it's we are in a good situation. And then I will observe this to the 14, and I will now provide a weighted score based on the 14 days by giving an important score to the just day before, a smaller score to the 2 days before, and etc. And my score will be some kind of percentage, which is a percentage of safety. Okay. And to make it easy for people, I will create classes. So it's a risk if less than 20% is satisfied, is a low risk. If between 20 and 40% satisfied, is 40 and 60% intermediate. We are safe, it's between 60 and 80, and very safe is not. Okay. So this classification will be updated every day, and you will have a table on the website. You can see this classification, and you can see how it had been varied during the last 21 days. Okay, so let me show you on the website. So this is my website. So if I do COVID data website, so it will go to the website. This is the front page. Okay, so you have tabs like latest update, previous 14 days, cases by week. I will go through them one by one. So on the front page is the worst situation. So this one I had updated today in the morning. So it's the update about the yesterday though.
Sorry.
And then, yeah.
We are not able to see the screen you're talking about.
Sorry, yeah, of course, I have to change that. Sorry, I will do that. So thank you very much. Firefox, here it is. Is okay?
Yes, it's okay, Mr. Malouche.
Yes, it's okay like that.
Okay, good. So the front page, remember that the address, I will write it again. So COVID-19 data.website. So the front page is the worst situation on the global. So until yesterday, 21/7, so I thought I updated this in the morning, we have 14,000,1917 cases. So today we had already reached the 15 million. We had a total of 1,600,000 with a total of recovered, etc. The mortality rate is 4%. The new cases yesterday is 200,000, and the active rate is 37. So if you can see this, I mean, this turns to green when it's less than 10%, etc. So there's some kind of colors. And then you will know here the cases by 1 million population, the death by 1 million population, the recovered, the active, and this is the RT estimated on all over the world. It's 1.01. I mean, I tell you, it's still higher than 1 for the world. So it means that the pandemic is still growing. Then, what you can see here? So on the last 50% of the cases, it means about 7 million cases, was detected in the 41 days, the previous 41 days. Remember here, I gave you the number of days. This is the first detected cases in China. So in 41 days, we had already detected 7 million. So if this growth is linear, let's say, it should be on the 100 days. So it tells you here that the disease is really having a fast growing in the world. Okay, are you still here? Hello?
Yes, we are hearing you.
Yeah. Okay, good. So in the last four days, actually, we have detected the last million. So if we continue like this, like every 4 days, we detect 1 million. So in 10 days, we will have 10 million. So like in a week, we may have go to 24 million, or in 15 days. In a month, we will be to 30 million cases. And the same thing also, of course, will increase for the okay? So what happened? Did you see each of these are buttons actually? So you can click on this and you go to the time series of the cumulative cases. So you can have all together. So the green one is the confirmed cases. The purple one is the recoveries. The blue one is the active. And the red one is the death, okay? So if you don't like this, you can have one by one, like this. And you can here play with the data, and you can zoom on one person. So let's go back here. So you can do the same. The mortality rate is a button too, and you can see how the mortality rate was along the time. So from 23 February was 3%. it reached 7% in 26 April. This is the time where the pandemic was very serious in Europe, and then it has grown down to 4%. So let's go back to the latest period. So the same thing you will have for the active rate. So here you have a tab about the active rate, and it's grown. Actually, it's good sign. I mean, it's because we are having more people recovered from the disease than new people getting the disease. Okay. What can you see? Yeah, so you can see on this tab, you can see the previous 14 days. So what I will do here, so I forget what's happening before the previous 14 days, and I start counting from the previous 14 days. So you can know the cases by continent. So right now, on the last 14 days, North Africa is the most affected, and Asia is taking the lead at the second position, okay? On South Africa, I can tell you it's going really very fast. 4 days ago, South Africa was the first one. And Africa is approaching also the other continent. So by region, the North Africa is still leading. So this is smallest region, Latin America and Caribbean. You can do by sub-region in the continent. So North Africa is still leading on South Africa. By countries, actually.
Is it North America, not North Africa?
Yeah. Sorry, North Africa, you're right, sorry. So by country, so the United States, even the last 14 days is leading, then Brazil, then India, actually. And before, I mean, South Africa was the fourth, and it's going to the fourth position. You can have also statistics about the United States here, and Florida is leading the states in the last 14 days, okay? And also you can go a lot, so you can have cases by 1 million continent, etc. Okay? So let me, and the cases by week now. Actually, the cases by week is a really good indicator how the disease is. So what I do, I aggregate all the statistics by week, okay? So this is, it started, did you see how it started in December 2019 with 1 case? And now, if we observe the last week we had 1,500,000 cases in a week. And these weeks are growing actually. This is this week, but we are at the second day of the week. Okay, so this is, you can have the same thing about the number of deaths, the number of recovery, and the number of the cumulative cases. So this is will be the fourth. So this is today the 15 million, and we have the cumulative death and the cumulative accident by case. Okay, you can see by day. So of course you will have this kind of variability because it goes up, and last one is about 2,100 cases. So now you can go through the classification. Remember the classification that I already explained it in my slides. So this is the table. I mean, most of you will recognize here a DT table from the package DT. So I recall the method. So if in this on the left, and you can here see the classification. So I can play with the column score and see who the country who's the lowest score he had. It means that El Salvador, he has maybe filled one of the conditions in the last 14 days, like 0.16%. So the United Kingdom is still in a very bad shape and only 6%. You can see the United States is 19%. So maybe most of you are interested to know what is the situation of Tunisia. Maybe I'm a little bit strict. We are in an intermediate situation because actually, I will show you later the Tunisian curve. We are starting having new cases. So on my data, I don't make difference between local or cases coming from other country. I don't have this data. If I had it, of course, maybe I will add this in the classification, and maybe my classification can be more accurate. Okay, so let me show you this, the safest country now. So the safest country, because maybe they still don't have any, like a lot of cases, Equatorial Guinea, Mali, Somalia, etc. So from here, you can actually visit, I mean, you can click on Cameroon, and you will take you to the dashboard of Cameroon. Okay, and you have all the same statistics that I was talking about it before on the Cameroon. Like on the reproduction number, if I click on it, I will have the time series of the reproduction number. So it's the estimation on the last until I think 60 days before. Okay, so you can have here by country classified in alphabetical order, and you can pick any one of them. Like I will go to the Tunisian if most of you are interested by that, and I will have the dashboard of Tunisia. So I will go here. You see there is a tab COVID-19 classification. So I go here. So it will tell me the situation today, and it will tell me that how my score had varied during the last 21 days. So we were in a green, in a safe case. We are maybe starting in an intermediate situation. It's not maybe very serious, but I think we should be careful about that. Okay, and this is of course it will be the same thing for all the country. If I go to the Senegal here, so same thing, it's low risk. You go to the COVID, so we're still on the red. And you can, of course, observe the cases by week. So still we're growing. So like if I go back to Tunisia and I go back to the cases by week, did you see? So this was the phase during the lockdown. We didn't have cases, and now we start having some cases growing. Okay. So what can you see else? So let me go back here. So you can see the situation in Africa. So did you see here? I clicked on Africa, so I got the situation in Africa. So we still have 700,000 cases in Africa. The RT is higher than 1, so we have to be careful. And in the last 24 days only, the first cases was introduced or started detected in Africa in almost 159 days before. But the 50% means like the 350,000 were detected the last 24 days. So we are really, I think, in a growth situation. Actually, if you go to the cases by week, you can see it's growing. This is the number. It's not even the cumulative number. Okay, and you can, so on the Africa, you can go to the sub-regions. Like here, I can do Northern Africa, like Northern Africa with the countries like Algeria, Egypt, Tunisia, Morocco, and so on. Okay, so you can play with this. You can go to the United States, etc. So I've been adding some new things actually. So I've been adding some Tableau dashboard like this here. So you can play with this. So this is okay. So these are dashboard. You can visualize the whole situation in the world actually. So let me put all together. Okay. So on the x-axis is the number of days, and on the y-axis is the death by 1 million population. Actually, you can change. You can change the active by 1 million, and you will see your graphic change. And you can just pick Africa, so you will have only African country displayed here. Okay, so you can see like some information about a country like Algeria, Tunisia, Angola, and so on. Okay, and this is also, I'm putting some dashboard, and I will add more and more every day. Okay, I hope it's not too long. I thank you very much for your attention here, and I'm happy to answer to all your questions if you have questions, of course.
Thank you, sir. Thank you very much for this presentation. It was really awesome and very, very clear. Thank you very much.
Okay, thank you.
And your website is just amazing.
Thank you, thank you.
So here we have a few questions. I have a question here. Someone wants to know, how did you solve the negative numbers problem?
So actually, I can show you the code. So we have to confront two data, okay? First of all, we have to pick the right, so there's on one data, it can be negative, on another one, it cannot be negative, positive. So we'll use the second one, okay? Then at the end, actually, I may have really few of the negative, okay? So what I did, I just used them as a missing, I made them as a missing value, and I used an imputation algorithm for that, okay? You know, here the data has at least 30,000 observations. So, and maybe the negative are about 100 or 80 observations. That's the solution I have. I prefer, this than, the negative, maybe they're also correct information because maybe, you know, they find that they're positive and next day they're not or something like this. So to avoid all this question, I had to write a code with an imputation code when it's negative, and by using and by playing with the both R packages. Okay. Okay.
And another question is, is there a metric for test positive rate?
Is there
He means percentage.
You talk about the test, the positive COVID person.
Yes,
I'm not understanding this question. Actually, I'm not a doctor, so these are the data about positive, people detected positive. There is a data about testing. I'm not using it, and I don't know how much is accurate. So persons positive versus total. I agree with you. This data actually is not available for all countries. And right now I'm not working on it, but I may include it in the website too. But I agree, I understand what he wants to do to have. Since it's not actually available. Yeah.
What he meant actually the percentage positive versus total tests. This
I didn't. I'm not working on the test data at all now. I'm not. Okay, I'm not. Yeah, but it's not. I mean, I'm thinking about it. I'm not working.
Okay, so also we have another question. Someone said, have you considered linking this impressive work with environmental layers like temperatures? So, I think he means including temperatures like a feature in your
let's
analysis.
finish this. Let's do this first. Yeah, it's an interesting question too. I mean, a temperature for sure is. The weather data to include on this. I mean, I think that time I need to hire a team.
Yeah.
All of them are good questions about. To understand.
I will be glad to join your team, sir.
Okay, you're welcome.
I will be glad to join. I love this kind of analysis.
All welcome. Yes.
Okay, so we have, I think, another. Iman asked if you can show us a part of your R code, so we can learn new tips in R.
I don't know. I mean, it's. I'll show you my my R Studio. Okay. Studio data. This one. Okay, I'll show you. Do you see that? Share. Okay. Okay. Hold on. Here the R Studio code. Okay. So I will show. So this is on any website, you know, you need to have an index 5. Okay, so this is the index. Actually, I didn't. I write a code who writes this index. So I will show you some part of it. So do you see here, there is a file called code RMDS. Okay. So the idea, what you do, so first did you see, I mean, all the dashboard looks similar actually. Do you understand? So if you run one, you can run all of them, okay? So the idea is to first run your first dashboard and with some particularity. So if you can note here, so that the dashboard concerning Africa has some other features that you won't find in a dashboard concerning a country. So you have to also think how to organize your data in that way. So what I do, actually, this is a code. Did you see that? This is a code. So written from a first dashboard. Okay. And so I have this code. I have other codes here to write the dashboard of the country. I have a code to write the dashboard for the states of the United States. I have the code for the regions. I have this code. So like when and this is already written. So now it's ready. And when I wake up, like in the morning, I have to run this code, all of them. So this is update all the RMD file. Did you see here? There's a lot of RMD file. Okay. And as the Git tab in my RStudio to update the website. Okay. I mean, it's a lot. It's a work. It's funny, but it's good too. I mean, I think you can do that too. I mean, you are all much more younger than me, so you have more time.
I have another question from Kauthar. She asked, which methods are used for negative numbers imputation?
Good question. I'm using actually easy package, the E1071. There's a method based. I told you it's the number of negative is low, but I don't want like on my visualization when you turn on and you visualize the time series on the case and you see negative. This is like make me crazy. So I use the one. So it's basically takes the median. I like the K neighborhood solution. It's very easy one. I didn't do any difficult one.
Thank you. Another question is how to use this statistics to convince people to be more careful.
I mean, when you see red colors, you should be careful in life. So on the classification, I'll show you. So here I share again the map. So I have a map actually on the website, and the map I did the map with here the map here it is. So this is the map of the classification, and I look to this map is coming so every day. I mean, I don't see most of the colors. I mean, the green actually looks safe, but the orange is the intermediate, the pink. I mean, this is the Tableau colors, light red, and the red are the risky situation. And intermediate, I mean, we are mostly close to I mean, we are not at the end. I mean, because what we keep talking in Tunisia, oh, we finish it with the COVID, I think this doesn't make sense for me at all. We have to be careful. Still, it's not finished. Okay, so I observe this every day, and I can see how the colors are turning from day to another one. Okay, and this map actually will be it's updated every day too.
Okay, so. I think I have a suggestion, not a question. So
sure.
Yeah, would it be possible to include animated maps in the dashboard that will be better show the special trends?
Yeah, of course, yeah, absolutely, yeah, we can. I mean, if you, yeah. if you want, I can have another suggestion actually. If anyone has, you know, this kind of beautiful visualization, I don't know, I mean, and I can host his visualization, but of course, put in clearly that this was done by you, not me. I can use this website as a support to put a lot of kind of visualization about the COVID together. This is also make me happy a lot. By the way, I mean, I'm not. So did you see? I mean, on the website, there's no ads, nothing. I mean, I'm doing this as a free person actually, because I am, you know, I'm a researcher at public university. I'm not getting any fund with this. I'm fine with that. I don't want anything to. So if someone is like me, I mean, he's very into open source tools in Statistic, I would love to host his visualization in this website.
Yeah, I think that's all. I think we are done with the questions. I don't know if anyone have other question. Yeah, someone, Iman Al-Hassani, told you it would be great if you share with us your experiences in R and data visualization. I think we will share with the participant our website. Your website.
Yeah,
sorry.
with pleasure.
Yeah, your website is, I think, yeah, actually, Dr. Malouch has a website in which you can find his R codes and also visualization and some courses, courses. Yeah, we will share it. Yeah.
Yeah, of course. Yeah, you just write to me. Yeah, of course. Yeah.
Okay.
Okay.
So, any questions?
I see a question like this with the link.
Yeah, Karima said, does your data comply with those presented by?
Yeah, I mean, this is the. I know. I mean, I showed that I showed that website too. This website uses. I mean, the data. We have almost the same data. The only difference, I just take the data on 24 hours before. I don't have live data like he has here. That's it. But we have exactly. I'm using the same data. I'm using the data. So I showed this website on R. That data is the same on the WHO. Cases.
We can't hear you very well.
I saw that the internet was unstable. So I told you I'm using the same data as that website. It's on GitHub. I showed you the link, and that link I can share again with you my website. So I'll show you the website. Where's the website? Where's the file? Okay. So if you go to here's my website. So if you go to About, so you have the slides and you have the links to this is the data, and you have the link. I mean, I try to explain everything. Okay.
Yeah, this is the same data actually.
Yeah. It is the same. It is.
I think all COVID websites use the same data.
Yeah, of course, yeah. I mean, these people are really doing a great job. The second one is another, I think, Chinese researcher, and I think he has some different sources, but it's almost the same. I told you I have a code. I didn't show that, a code that compares between these two data, and let me tell you, 97% is the same. Maybe less, 96%. Okay.
Okay. Other questions, or we can finish the meeting? Does anyone have a question?
Welcome, Karima. I think you have end up with questions.
Okay. Okay.
So thank you very much, Mr. Malouche, for this presentation. It was really impressive.
Thank you all. Thank you. Thank you. I hope I wasn't fast, but thank you. And if you need any question, feel free to write to me. So my contact on the website. I will be happy to answer. Thank you.
Yeah, we will also share our website, your website. Sorry, I said our website.
Yeah,
we will share your
our website.
We will share your website with the participant, and also in our social media of Our Ladies.
Remember, COVID-19 data.website, so easy to memorize.
Yeah.
Okay.
So that everyone can reach you and ask you their question.
Thank you, Email.
Okay,
so
thank you.
And you may review the webinar on our YouTube channel as you were live.
Yeah, we will share it in your YouTube channel. Also,
okay, I forgot I was live on YouTube. I'm not bad yet. I forgot that.
We were live in YouTube, and we will share it also with our ladies community worldwide.
Okay.
So,
good. Thank you, girls. Congratulations. Great job. Really, very good what you're doing.
Thank you, Mr.
Thank you. Thank you very much, sir. And also, we hope that we can have you in another meetups.
Of course, yeah. Of course. For sure, we want to make time together. For sure. Okay, good. Thank you. Have a nice evening.
Bye,
everyone.
Bye. Have a nice evening. Bye.
Thank you. Bye. Bye.